Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on Thevenin's theorem. For the following network, find the Thevenin's equivalent. Thevenin's theorem states that any linear complex network except the load resistance can be replaced with an independent voltage source VTH in series with a resistor RTH. So according to the Thevenin's theorem, the given network can be represented as a voltage source VTH in series with resistance RTH. So to find the Thevenin's equivalent of the given network, we have to find the open circuit voltage VTH and Thevenin's resistance RTH. Let us find Thevenin's equivalent resistance RTH. To find Thevenin's equivalent resistance RTH, replace all independent sources in the network with its internal resistance. There are two independent voltage sources in this network, and these two independent voltage sources are replaced with its internal resistance. So the given network will be redrawn as shown. As 10 ohms and 15 ohms are connected in series, the above network can be redrawn as. Here there are two 25 ohms resistors connected in shunt. So effective value of two resistors connected in shunt is given as R1 R2 divided by R1 plus R2, where R1 and R2 are the two resistors connected in shunt. As R1 is equal to R2 is equal to R in this network, effective value of the shunt combination is R divided by 2. So Thevenin's equivalent resistance is equal to 12.5 ohms. Now let us find Thevenin's equivalent voltage VTH. Thevenin's equivalent voltage VTH is the open circuit voltage of the circuit, that is voltage between terminals A and B. Now applying superposition theorem, we can write VTH is equal to VTH1 plus VTH2, where VTH1 is the component of VTH due to 50 volt source with the 100 volt source replaced with its internal resistance, and VTH2 is the component of VTH due to 100 volt source with 50 voltage source replaced with its internal resistance. So according to superposition theorem, we can write VTH is equal to VTH1 plus VTH2, where VTH1 is the 50 voltage component and VTH2 is the 100 voltage component of VTH. Let us find VTH1. VTH1 is the voltage drop across 25 ohms resistance. So according to Ohm's law, VTH1 is equal to I1 into 25. VTH1 is equal to 25 I1, where I1 is the current sourced by the independent voltage source of value 50 volt. To find I1, apply KVL. According to KVL, the loop equation becomes 50 minus V10 minus V25 minus V15 is equal to 0. According to Ohm's law, V10 is equal to 10 I1, V25 is equal to 25 I1, and V15 is equal to 15 I1. Equation 1 becomes 50 minus 10 I1 minus 25 I1 minus 15 I1 is equal to 0. So the equation becomes 50 minus 50 I1 is equal to 0, or we will get I1 is equal to 1 ampere. Therefore, we can write VTH1 is equal to 25 I1. As I1 is equal to 1 ampere, we will get VTH1 is equal to 25 volt. Now let us find VTH2. To find VTH2, the 50 voltage source is replaced with its internal resistance short circuit. Now we can see that 10 ohms resistance and 15 ohms resistance are connected in series. So we can redraw this circuit as shown here. As 25 ohms resistance is connected between A and B, VTH2 is equal to V25. VTH2 is equal to V25. Applying voltage division rule, we will get VTH2 is equal to 100 divided by 25 plus 25 into 25. So VTH2 is equal to 50 volt. Finally, VTH is given as VTH is equal to VTH1 plus VTH2, that is equal to 75 volt. So VTH of the given circuit after applying superposition theorem is 75 volt. So the Thevenin's equivalent of the given network becomes 75 voltage source in series with 12.5 ohms resistance. Thanks for watching Circuits Analytica. Enjoy learning.